Dear students, Unit 3, Semiconductor Devices and Applications. In BEEE subject for Civil Department. Types of semiconductors. So there are two types of semiconductors. One is intrinsic semiconductor and the second one is extrinsic semiconductors. In intrinsic semiconductor, it is having tetravalent property. For example, silicon and germanium. It is in the pure form. Extrinsic semiconductor, so pentavalent. So P type and N type are the examples. It is not in the pure form. So types of diodes. Some major types of diodes are given. One is Zener diode, second varactor diode, third light emitting diode, fourth photodiode, fifth laser diode, sixth Schottky diode, seventh pin diode, eighth tunnel diode, ninth small signal diode, 10th large signal diode, 11th Schottky diode. Some definitions in this topic. Semiconductor is a device that has the resistance of an insulator and the conduction of a conductor. That means semiconductor is a combination of insulation property and conduction property in a conductor. Most devices are made up of silicon or germanium. Doping. It is the process of adding impurities to the semiconductor device to increase the number of free current carriers. Current carriers. Majority carriers are the predominant carriers in the semiconductor material. If it is an N-type material having arsenic, it is having electrons and it is negative. If it is P-type material, say aluminum, then it is having holes and it's positive. Light emitting diode, LED. An LED emits light when forward biased. LEDs are available for either infrared or visible light. High intensity LEDs are used in large screen displays, traffic lights, automotive lighting and home lighting, etc. The symbol of LED is shown. Photodiode. Photodiode is a device that operates in the reverse bias. The photodiode exhibits an increase in reverse current with light intensity. So a diode in which the reverse current varies directly with the amount of light. The symbol is shown. Diode. So diode is a device having two electrodes. It's a two-terminal device made up of semiconductor crystal. It's also called as PN junction diode. Diode schematic diagram. So a diode is having a positive anode side and a negative cathode side. The conventional current flow from negative to positive. For easy understanding, the cathode sounds like K. Block diagram of a PN junction diode. Here the junction barrier is where recombination occurs and a very little current carriers in this. So P-type doped with aluminum producing excessive holes and is positive. In N-type doped with arsenic producing excessive electrons and is negative. So in the figure, the red color shows the P-type and the green color shows N-type. The center white color is the junction barrier. Diode biasing. So biasing is giving the power supply to the diode material. When you have the positive terminal connected to the P-type material and the negative terminal of the supply connected to the N-type material, this is the forward bias. Junction barrier. Here in reverse biased, the junction barrier is much larger and the current flow has stopped. So in forward biased condition, the junction barrier is almost gone. That means no junction barrier. Here the current flows at its maximum value. Then characteristics of PN junction diode. So one is forward bias characteristics and the second one is reverse bias characteristics. In forward bias, the external battery makes the anode more positive than the cathode. The current flows in the direction of the arrow in the symbol. Reverse bias. External battery makes the cathode more positive than anode. So a tiny current flows opposite to the flow. So definition of diode current and voltage. Forward bias condition. When diode current is greater than 0 milliamps and the diode voltage is more than 0 volt, then it is forward biased. When diode current is less than 0 milliamps and diode voltage is less than 0 volt, then it is called reverse bias. So in forward bias, it's the condition that allows current through the PN junction. A DC voltage is applied to bias a diode. Positive side is connected to P region, anode, and negative side is connected with N region, cathode. So V bias must be greater than the barrier potential. VA characteristic for forward bias. So in the graph or characteristic curve, we have seen the forward bias characteristics. The current in forward bias called forward current and is designated IF. So at 0 volt across the diode, there is no forward current. With gradual increase of the diode biasing voltage, the forward voltage and forward current increases. So as per the diagram, a resistor is seen in series will limit the forward current in order to protect the diode from overheating and permanent damage. A portion of forward bias voltage drops across the limiting resistor. Continuing increase of forward voltage causes rapid increase of forward current, but only a gradual increase in voltage across diode. So in reverse bias, it prevents current through junction. That means the depletion layer is larger than in forward bias. Positive side of B bias is connected to the N region, whereas the negative side is connected with P region. So VA characters for reverse bias. So with 0 voltage reverse voltage, there is no reverse current because the depletion layer is very large. There is only a small current through the junction as the reverse voltage increases. So at a point, reverse current shoots up with the breakdown of diode. Thus, the voltage called breakdown voltage. This is not normal mode of operation. After this point, reverse voltage remains at approximately breakover voltage. That means reverse breakover voltage, but reverse current increases rapidly. This breakdown voltage depends on doping level as per manufacturer taste. This is the complete VI characteristic curve of PN diode, junction diode. So in the forward current increases rapidly in the forward bias after threshold voltage. Similarly, in the reverse bias, the leakage current is very minimum. At breakdown voltage, the current rapidly increases. Knee voltage. So in the figure, knee voltage is shown in the forward biased region. The minimum amount of voltage required for conducting the diode is known as knee voltage or threshold voltage or cut-in voltage. So it is the minimum amount of voltage given to the diode for forward conduction. The forward voltage at which the current through PN junction starts increasing rapidly is known as knee voltage. Knee voltage of germanium diode is 0.3 volt. Similarly, knee voltage of silicon diode is 0.7 volt. Reverse breakdown. As the reverse bias voltage increases, the electric field in the depletion region increases. Eventually, it can become large enough to cause the junction to break down so that a large reverse current flows. So if need any references, you may go to the website or the book. Thank you.